So in this video, we want to pick up with problem number 13 on our review for test 3. Problem number 13, if A equals $1,400, P equals $1,200, and T equals 5, solve A equals P times 1 plus R raised to the T power for R. So it's a pretty straightforward problem. Number 13, we again have the formula A equals P times 1 plus R raised to the T power. We're told in the problem that A equals 1,400, P equals 1,200, T equals 5. So if I fill those values in, I have 1,400 equals 1,200 times 1 plus R raised to the 5 power. So in order to solve for R, I need to get rid of the 1,200 from the right side. I need to get rid of the 5 from the right side in order to be able to solve for R. So I'm going to start by dividing both sides by 1,200. Incidentally, the units on these were dollars. So when I divide by $1,200, the units divide out. So let's see what 1,400 divided by 1,200 is. So 1,400 divided by 1,200 is 1.16, and then the 6 keeps repeating. So 1.166666667. I don't want to round because that could cause error. And that is equal to 1 plus R raised to the 5th power. Well, to get rid of the 5th power, I'm going to take the 5th root of both sides. So I'm going to find the 5th root of both sides. So on the right-hand side, the 5th root of 1 plus R to the 5th power will just be 1 plus R. That's kind of the point. On the left-hand side, to find the 5th root of 1.166666667, that's the same as doing 1.166666667 to the 1/5 power. So that's how I'm going to enter that in my calculator. So 1.166666667 raised to the 1/5 power, that is 1.0313100307. So 1.0313100307 equals 1 plus R. So if we subtract 1 from both sides, R is going to equal, well, 1.03 blah 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 minus 1 is going to be 0.031310307. And so that is an interest rate. So that would be 3.1310307% if I multiply by 100%, and that moves the decimal point 2 places to the right. Now typically we would want to round that, and so if we round that to say 2 places, then that would be about 3.13%. Let's take a look at number 14. So in problem number 14, Bernie purchased a riding lawnmower for $1,320. The store offered him a 3-year add-on loan at an annual rate of 8.25%. How much interest will he pay, and what are his monthly payments? So looking here at number 14, again we know that Bernie's lawnmower costs $1,320. So that's the price of the lawnmower, and he is going to pay a 3-year loan, so T equals 3 years, and the interest rate is 8.25%. So we had 2 questions: how much interest will he pay, and what will his monthly payments be? Well, this is going to be just simple interest. So interest equals principal times rate times time. So his principal is going to be $1,320. That's how much he's borrowing. His rate is 8.25%. So as a decimal, that's 0.0825. And again, he's borrowing that for 3 years, so times 3. So if I bring in my calculator, $1,320 times 0.0825 times 3, so that is $326.70 in interest. So $326.70 in interest. So what's his monthly payment going to equal? Well, his monthly payment is going to equal his principal plus the interest divided by the number of payments that he must make. Well, his principal is the $1,320. His interest, we just figured, is $326.70. And the number of payments that he's going to have to make, well, he's got a 3-year loan and he's going to make a monthly payment. So 3 years at 12 months per year is going to be 36 different payments. So if we take the $1,320 plus $326.70, that is $1,646.70. $1,646.70, and that's paid over 36 months. So if we divide that by 36, that is $45.74. So his monthly payment is going to be about $45.74. Now I do want to point out something. If he makes 36 payments at $45.74, then he's going to actually pay back $1,646.64. He's not going to get to the 70 cents. So at some point he's going to have to pay that other 6 cents. So in some of the payments he might have to pay an extra penny. In fact, in 6 of the payments he'd have to pay that extra penny in order to pay off the total amount. Let's take a look at number 15. We'll do that on a separate sheet. So in problem number 15, we want to use the unpaid balance method to calculate the finance charge on Johanna's credit card account. If last month's balance was $1,350, she made a payment of $375, she bought hiking boots for $120, and she returned a jacket for $140, and we're going to assume her interest rate's 21%. So, number 15, we know that the balance for last month was $1,350. So what we need to do is figure out what the balance is going to be for this coming month so that we can figure out what the finance charge is going to be for that. Well, if her balance last month was $1,350, she's going to have to pay a finance charge for that. And so her finance charge is the interest, and we calculate that using the simple interest formula. So she's going to have interest on the $1,350, that's the principal, times the rate, which is 21%, so times 0.021, times the time, which is 1 month, so that would be 1/12 of a year. So if I bring in my calculator, $1,350 times 0.21 times 1/12 of a year, so that's going to be $23.63 if I round to the nearest penny. So Johanna has $23.63 that she has to pay in interest for this $1,350 balance. Now, so I need to find her new balance. So her new balance for this month is going to be the $1,350 from the previous balance plus the $23.63 that she has to pay in interest for that $1,350. And then we were also told that she made a payment of $375, so we can subtract that payment of $375. We know that she bought hiking boots for $120, so she's going to have to pay interest on that, $120. And then she returned a jacket for $140, so she's going to get a $140 credit that she doesn't have to pay interest on. So if I add that all up, $1,350 plus $23.63 minus the $375 payment plus the $120 purchase minus the $140 return. So that means her balance for this month is $978.63. So what's her finance charge going to be on that? So her finance charge this month, again, that just means the interest. So that's going to equal the $978.63, that's the principal, times the interest rate, 21% in decimal form, so times 0.021, times the time, which again is 1 month, so that's 1/12 of a year. So if I take the $978.63 times the 0.21 times 1/12 of a year, then that is going to be $17.13 in interest. So she's going to have a $17.13 finance charge this month. Let's take a look at number 16. Piers is saving for his retirement by putting $175 each month into an ordinary annuity. If the annuity pays an annual interest rate of 9.35%, how much will he save for his retirement in 10 years? So this is an ordinary annuity problem. So we're going to use our ordinary annuity formula. A equals R times the quantity 1 plus R over M raised to the n power minus 1 over R over M. So we're going to use this formula to do our calculation. And in this case, we were told he's going to make a regular payment of $175 each month. We know that the interest rate is 9.35%, so lowercase r equals 9.35%, which is 0.0935. He's making monthly payments, so M equals 12, and he's going to do that for 10 years. And so that means the number of times money's deposited, and the number of compound interest calculations and so on is going to be 12 times 10, which is 120. So N in our formula is going to equal 120. So all we have to do to figure out the future value that he's going to have 10 years from now is plug these numbers into our formula. So that's going to be 175 times 1 plus 0.0935 divided by 12, and that gets raised to the 120th power because n's 120, minus 1, and that's all over 0.0935 over 12. So if I can figure out this calculation, then we have it. So I'm going to do this on the calculator. So I'm going to do this a little bit at a time. So if I take 0.0935 divided by 12, which I have both here and here, that's going to give me that. So 0.0935 divided by 12, that's going to be 0.0077916667. So that's going to go both here and here. So I really have 175 times 1 plus 0.0077916667 raised to the 120th minus 1. And then this is going to be 0.0077916667. Don't want to round that because that will cause error. Now 1 plus 0.0077916667 is going to be 1.00779667. So I think I'm going to just go ahead and move forward with this on the calculator. So I'm going to do 175 times my numerator. In my numerator, I'm going to have 1.0077916667, and that gets raised to the 120th power minus 1. Close my numerator. So again, this is 1.0077916667 raised to the 120th, so I just entered that all as one number there, minus 1. Notice I put that all in parentheses because that is my numerator. And then I need to divide that by my denominator, which is 0.0077916667. And so if I do that, that gives me $34,543.31 if we round to the nearest penny. So $34,543.31. So if Pierce makes these $175 payments for the next 10 years each month, then at the end of that 10-year time period, he's going to have $34,543.31 in his retirement account. Let's take a look at number 17. Number 17. We want to calculate the finance charges for the following credit card account for August, which has 31 days, using the average daily balance method. So July's balance was $275, and the annual interest rate is 18%. So on August 1st, the balance was $275. On August 6th, a payment was made of $75. On August 12th, there was a charge for $115. On August 19th, there was a charge for $20. And on August 24th, there was a charge of $16. And again, we're wanting to use the average daily balance method. So we've got to figure out what the average daily balance is in order to be able to calculate the interest. So for problem number 17, I want to think about the dates and the balance on the dates. So on August 1st, the balance was $275. And in fact, that balance stayed that until the 5th. And then on August 6th, there was a payment made of $75. So if we take the $75 payment off of that, then that means the balance dropped to $200 on August 6th. And then it stayed that from August 6th through August 11th. On August 12th, a purchase was made of $115, so the balance at that point went up to $315, $200 plus the $115 purchase, and it stayed $315 through August 18th, and then on August 19th, another charge was made for $20, so now the balance is $335 because now there's $20 more on that balance, and it stayed that through the 23rd, and then on August 24th, another charge was made for $16, and so if we add the $16 to the $335, that brings the balance to $351, and it remained that until the end of the month. So it remained that from the 24th through the 31st. So now I want to think about the number of days. So the balance of $275 that was owed for 5 days. That was from August 1st through August 5th. And then the balance of $200 was owed for 6 days. That was from August 6th through 11th. So 6, 7, 8, 9, 10, 11. And then August 12th through 18th, we owed this balance of $315, and that is 7 days that we owed the $315. And then from August 19th until August 23rd, we owed $335, and that is 5 days that we owed that amount. And then finally, we owed the $351 here till the end of the month, and so that was 8 days that we owed that amount. So 24 through 31. So 24, 25, 26, 27, 28, 29, 30, 31. That's a total of 8 days. So we're going to multiply each of these. So I'm going to take the number of days times the balance that was owed. So if we take 5 times 275, that is 1,375. If we take 6 times 200, that is 1,200. If we take 7 times 315, that is 2,205. 5 times 335, that is 1,675. And last but not least, 8 times 351, that is 2,808. So if we add that up, so 1,375 plus 1,200 plus 2,205 plus 1,675 plus 2,808, that is a total of 9,263. And so our average daily balance is going to equal that 9,263 divided by 31, because there are 31 days in August. So if I take that 9,263 divide by 31, that is an average daily balance of $298.81. So $298.81, that's technically approximately equal to. So our finance charge, which technically is the interest, is going to equal the principal times the rate times the time, where the principal is that average daily balance. So that's going to equal the $298.81 times the interest rate. If I bring back in number 17 here, our interest rate is 18%. So times 0.18 times time. Now in this case, this is 31 days out of 365 days. So we're going to write that as a fraction of a year. So if I bring my calculator back in here, $298.81 times 0.18 times 31 divided by 365, that is equal to $4.57. Again, technically that is approximately equals to there. So our finance charge for the month of August is going to be $4.57. Again, really what that means is that's the interest that we're paying for that average daily balance. So the tricky part here is you got to find the average daily balance. Once you find the average daily balance, then you just use the simple interest formula. Let's move on to number 18. Number 18, find the monthly payment needed to have a sinking fund accumulate to $2,000 in 36 months if the annual interest rate is 6%. So again, for this problem, number 18, we're going to be using our annuity formula. So our annuity formula is that A equals our regular payment times 1 plus R over M raised to the nth power minus 1 over R over M. And in this case, we're wanting to accumulate $2,000 in 36 months. So in other words, we want this amount to be the $2,000, and so we need to figure out what our payment needs to be. So for this problem, the A part equals $2,000. We're looking for R. R equals what? Our interest rate is 6%, and we're doing that in 36 months. So our interest rate is 6%, which is 0.06. Now this problem doesn't specifically say that it is compounded monthly, but we are making a monthly payment, so that compounded monthly part is understood. So in other words, M equals 12 because we're making monthly payments, and we're going to do that for 36 months, so N equals 36. So directly in that problem we were told what N is, but really what's happening is that's 3 years. So 12 times 3 equals the 36. So again, our question is, how much do we need to pay each month in order to accumulate that amount? So if we fill in what we know, $2,000 is going to equal R times 1 plus 6%, so 0.06, divided by M, so 12, raised to the n power, so 36, minus 1, and that is over 0.06 divided by 12. So if we clean this up, 2,000 equals, well, 0.06 divided by 12 is 0.005. So we have 1 plus 0.005, so that's 1.005, and that's being raised to the 36th power, minus 1, and 0.06 divided by 12 is 0.005. So I'm going to figure out what that is, and then we'll solve. So parenthesis 1.005 raised to the 36th minus 1, close parenthesis, divided by 0.005, that is 39.33610496. So we have $2,000 equals R times 39.33610496. So R is going to equal 2,000 divided by that. So if we take 2,000 divided by the 39.33610496, that is equal to 50.84. So we're going to have to make a monthly payment of $50.84 in order to accumulate the $2,000. And technically, if we round that down to 84 cents, technically we won't quite get to 2,000, so we really probably should round that up, but if we do that, then we'll get a little over $2,000. So approximately $50.84 or $50.85. So let's pick up with problem number 19 on a new video.